Hi everyone, we want to solve for the value of x in this nice expression. So to do that, we have solution. First thing, we put our question down. So from here, what we need to do next is to raise the power of the left hand side, both 5 raised to the power x and 4 raised to the power x, to exponential 2 over 2, which gives us 5 raised to the power x into bracket exponential 2 over 2 minus 4 raised to the power x into bracket raised to the power 2 over 2 equal to 85. Now from here, what we need to do next is to use this identity a raised to the power m into bracket raised to the power n is written as a raised to the power n multiplied by n, which is simply written as a raised to the power n into bracket m. So we transform this using this identity. So the next step becomes 5 raised to the power 2x over 2 minus 4 raised to the power 2x over 2 equal to 85. And this can be written as 5 raised to the power x over 2 into bracket raised to the power 2 minus 4 raised to the power x over 2 into bracket raised to the power 2 equal to 85. So from here, we let 5 raised to the power x over 2 equal to a, and 4 raised to the power x over 2 equal to b. So we substitute that into the expression. We have a squared minus b squared equal to 85. Then from here, this appears to be difference of 2 squared, so which can be written as a plus b into brackets, open another bracket, a minus b equal to 85. Now from here, we simplify this right hand side. Then we have a plus b into bracket, open bracket, a minus b, close the bracket, 17 multiplied by 5 will give us 85. So having done this, we equate this 17 to this a plus b, then 5 to a minus b. Then we have a plus b equal to 17, then a minus b equal to 5. This will be equation 1 and this will be equation 2. So we add equation 1 and 2 together. We add both equations together. So to add that together, we have a plus a will be equal to 17 plus 5. And that will give us 2a equal to, this added together will be giving us 22. Then we divide both sides by 2, and that gives us a to be equal to 11. So for b, we subtract a and b. Subtract equation 1, we subtract equation 1 and 2. So that gives us b minus into bracket minus b equal to 17 minus 5, and that will be given as b plus b equal to, this gives us 12. b plus b equal to 2b equal to 12. Divide both sides by 2. We have b to be equal to 6. So we can recall that our a is given as, so we recall that our a is given as 5 raised to power x over 2. So we put this value of a over here, Then we have 11 equal to 5 raised to power x over 2. Now from here, to solve this expression, we take the log of both sides. So we can write that as 5 raised to power x over 2 equal to 11. So we now have log of 5 raised to power x over 2 equal to log of 11. So if we bring this exponent down to the base, we have 2x over 2 log of 5 equal to log of 11. So from here, the next step becomes we multiply 2 from both sides. So we have x over 2 multiplied by 2 log of 5 equal to multiplied by 2 log of 11. Now this cancels out this. We have x log of 5 equal to 2 log of 11. We divide both sides by log of 5. We have x to be equal to 2 log of 11 over log of 5, which can simply be written as 2 log of 11 base 5. So this is our value of x when we have a to be equal to 11. Now for the value of b, when we have b to be equal to 4 raised to power x over 2, and b is given as 6, which is equal to 4 raised to power x over 2. Writing this, we have 4 raised to power x over 2 equal to 6. So we also take the log of both sides. We have log of 4 raised to power x over 2 equal to log of 6. We bring down this exponent, x over 2. We have x over 2 log of 4 equal to log of 6. And log of 6 can be simplified as log of 2 multiplied by 3. From here, we can write the right hand side as x over 2 log of 4 equal to log of 2 plus log of 3, considering the log identity. So that's what we use here. So from here now, we can now multiply both sides by 2. Then we have 2 multiplied by x over 2 log of 4 equal to 2 into bracket log of 2 plus log of 3. So here, this cancels out with this. We have x log 4 equal to 2 log of into bracket log of 2 plus log of 3. Now here we divide both sides by log of 4. So we have divide by log 4 divided by log 4, and this is written as, this cancel out this, so we have x equal to 2 into bracket log of 2 plus log of 3 over this log of 4 can be simplified as log of 2 power 2. Now we have x to be equal to 2 into bracket log of 2 plus log of 3, close the bracket, over this power, then come down to the base. So we have 2 log of 2. So, and this gives us these 2 to cancel out with these 2. So x will now be equal to log 2 plus log 3 over log 2. So which can simply be written as log 2 divided by log 2 plus log 3 divided by log 3. So this log 2 cancel out this log 2. That's our x. So x will now become 1 plus, this is log 2. So log 3 over log 2. So we can write this in the form of x equal to 1 plus log 3 base 2. So this is our second value of x when b equals to 6. So we are not done yet. We can verify this. To verify the value of x at a equals to 11 and the value of x at b equals to 6. So from our question, we have 5 raised to power x minus 4 raised to power x equal to 85. Will this expression be equal to 85? So we input this value for x, for a over here, and we input the value of b over here. When a equals to 11, we input the value. When b equals to 6, what is the value of x? So we put it at this side. To verify that, we insert this value of x at a equals to 11 to this term and this value of x over here. So we now have our next step to become 5 raised to power 2 log base 5 11 minus 4 raised to power 1 plus log base 2 3 equal to 85 question mark. So from here we move these 2 to the power. So we have 5 raised to power log base 5 11 power 2 minus, this will be split using the exponent rule, which implies if you have a power n plus m, you can split it as equal to a power n multiplied by a power m. So we split this as that. So we now have 4 raised to power 1 multiplied by 4 raised to power log of base 2 3 equal to 85. Would that be equal to 85? So from here, this can be written considering this identity. Base A raised to power log base A B can be written as B. So if we consider this, we can use it to express this and this over here. Then this become 11 raised to power 2 minus 4. 4 raised to power 1 become 4 multiplied by, this can be expressed as 2 raised to power 2. Then log base 2 3 equal to 85. Would that be equal to 85? So 11 raised to power 2 minus 4 multiplied by this 2 move to the power. We now have 2 log base 2 3 then power 2 equal to 85. Equal to 85. Now from here, 11 power 2 will give us 121 minus 4 multiplied by, this can now be written as, using this identity, we can now write this as 3 raised to power 2 equal to 85. Question mark. 121 minus 4 multiplied by 3 raised to power 2 will give us 9, and that will be equal to 85. Question mark. So we have 121 minus 4 multiplied by 9. We have 36 equal to 85. Question mark. So 121 minus 36 will be given as 85, which is equal to 85. So this means that LHS equal to RHS, which proves our value of X is correct when A equals to 11 and our value of X is correct when B equals to 6. Thanks for watching. Hope you enjoyed this video. If you do, please subscribe to the channel and then like the video and share it to your loved ones. And I will meet you in the next interesting lesson. Continue enjoying your maths lesson with the next video. Bye for now.